Unit 7.3, Similar Right Triangles and Geometric Mean. Today I'm going to teach you how to solve the equation of a right triangle problem. When solving a right triangle problem, most common mistakes are made when making the proportion and solving the equation correctly. The first theorem for solving a right triangle is if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. The theorem for geometric mean, the altitude, is in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of the altitude is the geometric mean of the length of the two segments. Last but not least, the geometric mean theorem for the leg is in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. First thing is first. You're going to draw the whole triangle and make sure you know the measurements of each labeled side. Next, you're going to draw the three similar right triangles and label the sides according to the information on the original triangle. Then you're going to set up a proportion for the problem. When you set it up, make sure that the variables are diagonal to the other variables and the numbers are diagonal to the other numbers. If you drew a triangle labeled RPQ, the length of the hypotenuse of the triangle RPQ would be over the length of the hypotenuse of triangle RQS. This is also equal to the length of the shorter leg of the triangle RPQ over the length of the shorter leg of triangle RQS. When you're done setting up your proportion, you can choose to multiply the numbers or variables together first. When you finish finding the product of both, write the equation to equal each other. When you get the product of the numbers, equal it to the variable to the power of 2. After you're done with that step, you have to divide from each side. The opposite of the variable to the power of 2 would be to find the square root. So after they are equal, find the square root of the number and equal it to the variable without the power of 2. Once you're finally done writing the square root of your answer, simplify the equation to lowest terms. This is our first example. As you can see in the top left box, that's our original triangle that we're going to start with, that we break down into the other triangles. Next, you're going to draw out the three triangles and label their sides. Then, you're going to draw the proportions and cross multiply for the product of both variables and numbers. Then you're going to equal the number to the variable to the second power. So 8 times 4 is 64, so you would equal it to x to the second power. Then you write out the square root of the number and equal it to the variable without the power of 2. So the square root of 64 equals x. Then you finish the problem by simplifying your answer to lowest terms. 8 square root of 8 equals x. We're going to try another example. In the left top corner, again, that's the original triangle that we're going to use. You know that the whole side is 2, and splitting is, did I say 2? I meant 8. How embarrassing. Okay, so then the number that splits the triangles into 2 is 2, and then we're going to use x for the side number. When you go over to the right, we did what we did in the last problem and put three triangles out since we separated the original triangle. Then next you go down to writing the proportion, so 2 over x equals x over 8. Then you cross multiply. 8 times 2 is 16 and x times x is x to the second power. Then you're going to cancel out both by finding the square root of 16 equals x. Then you're going to simplify your answer. 2 square root of 2 equals x. For our last example, number 3, in the top left box we have the triangle QRP. The length of RQ is x and the length of RS is 3. The whole length of RP is 9. So we go over and separate our triangles from the original triangle. The small triangle, the length of RS is 3 and RQ is k. For our large triangle, RQ is x and RP is 9. So you go down and cross multiply when you make your proportion. 9 over x equals x over 3. You multiply 9 times 3 equals 27, and x times x equals x squared. Then you square root 27 and equal it to x, since you take away from the sides, and to solve your equation all the way, you simplify. 3 square root 3 equals x. Thank you for watching. Hope you learned Unit 7.3 easier.